All right, thank you so much for the warm welcome. I want to introduce myself. Again, I'm Tanya Ladwig. I'm really glad to be here today. As he said multiple times, my title is the Vice President of Human Space Exploration, and I'm the current Orion Program Manager. Lockheed Martin's Space Division is home of 23,000 individuals that are working to solve our most pressing challenges in space. And I'm actually part of the commercial civil space line of business. And what do we do in the commercial civil space line of business? It sounds kind of obvious, but really we're building and delivering cutting-edge technology for lunar, for human, and deep space exploration. We also are doing it for weather and earth science and commercial satellite systems. So it's a really broad line of business that I work in. And as my title alludes to, I'm responsible for building and developing all the technology needed for human spaceflight, and specifically for Orion, which is a key component of NASA's Artemis mission. There's some great pictures here, but following that great panel discussion earlier today, we heard, I want to continue the conversation about a vision for the future of the lunar ecosystem. As a prime contractor and a very large employer in the space industry, Lockheed Martin has given a lot of thought to what the future of the lunar economy should look like and what it'll take to get us there. Last year's launch of Artemis 1 in November, we're coming up on the anniversary of it in a couple weeks, and the successful splashdown in December of our crew module. There are some great pictures there. I hope all of you got a chance to experience it at least a little bit. If not, get onto NASA's website and go look at the historical mission that we had. It was a 25-and-a-half-day mission. We went 1.4 million miles in the first human-rated spacecraft to go that far from the Earth and to go into deep space. And it was an incredible mission. But then, the next best part, where are we headed now? It's with Artemis 2, and we have our crew. So earlier this year, NASA introduced us to our crew. So I want to introduce you, if you haven't met them yet, to Reed Weissman, Victor Glover, Christina Cook, and Jeremy Hansen. He's actually the Canadian astronaut that's part of our crew. It was wonderful. They actually got to come out to our facility in Colorado this summer. They got to do some human-in-the-loop testing with our engineers and some early training. But the best part, they actually got to come meet our employees and our employees' families, and the kids got to ask all these astronauts incredible questions. It was a really incredible moment. But then as I took a step back from that and kind of was exhausted after that day, I was reflecting on the success of the Artemis 1 mission and meeting our crew and thinking about all it took to get us there, right? We had to, it took industry, the service module was delivered from ESA, from Airbus. It's international cooperation. All of that is needed as we look into our future lunar economy too. For a sustainable human presence at the moon, the development of a water-based, nuclear-enabled, commercially invested, cislunar economy is going to be critical. As the panel before me discussed, the future lunar economy will be complex. Just think of all the things you need to make a home on Earth: communications, transportation, power, adequate habitation and resources like food and potable water. Our vision of the future lunar ecosystem relies on reducing the barrier of entry for others so they can survive and thrive on the moon. As Lockheed Martin's Orion Program Manager, I would be remiss to not start with transportation, of course. I would like to talk a little bit about NASA's Orion program. Getting humans to the moon is the first step. And Orion is humbly, I think, the technology that exemplifies the principles crucial to that sustainable future lunar economy, really leveraging things like reuse and additive manufacturing. Today, the Orion spacecraft for Artemis 2 is almost fully assembled. We actually stacked our crew module and our service module just a couple weeks ago, and we're heading into environmental testing. So this is real, folks. Like, this is the spacecraft crew are going to fly on. And it's not just a one-off spacecraft. We've worked so hard as Lockheed Martin and our supply base to build this historical spacecraft, but it's not just a one-off. We are in full production. We actually have our crew modules for Artemis 3 and Artemis 4 being built in the high bay. As was mentioned earlier in my introduction, we're on contract to up to 8 Artemis missions, so we are procuring the hardware needed for those 8 Artemis missions right now. This production mindset and leveraging that high reuse, that's key to having that sustainable, reliable transportation of humans to deep space. We're working towards making our crew modules, that's where our crew live, more reusable, and we do that with some refurbishment, but we're actually reusing some of the avionics elements right now. So between Artemis 1 and Artemis 2, there are about 16 components that were reused between Artemis 1 and Artemis 2, things like our flight computers and our high-value equipment, all the things that are the inside, they can be reused from mission to mission. And as we move forward, this is really going to be key to having the substantial cost savings for each vehicle after vehicle for the Artemis missions. It isn't just about reusability, though, for Orion. Technologies such as 3D printing and augmented reality are enabling continued affordability and faster manufacturing and producibility of our spacecraft. The state of these state-of-the-art techniques, like 3D printing and additive manufacturing, are driving reductions in cost for each vehicle in the production phase of our program. On its first test flight of EFT-1 in 2014, so that was prior to the Artemis 1 mission, we had 4 vents that were additively manufactured as part of that mission, made out of nickel alloy. Fast forward to Artemis 1, we had over 100 parts of that spacecraft that were 3D printed, and then fast forward to Artemis 2, the one that's being built right now, it doubles that. So we're really starting to use additive manufacturing and 3D printing on our spacecraft. It's used for non-structural parts or moderately structural parts, so that it's not, and it's used with a variety of materials, things like polymers, titanium. If you're trying to picture on like, what would that be that's not structural on the spacecraft? Think of all the wire harnessing that goes throughout the spacecraft. When you have to create a space for it to be tucked away, those wire harness closeout panels, those are all 3D manufactured because they're kind of odd sizes, right? So something we can do that's non-structural. But all those things are making our Artemis Orion vehicles much more sustainable and much more efficient as we go forward in cutting costs. We're also using augmented reality. I know that's a big buzzword, but it's really important when you start looking at production. So we're using that technology to help speed how our make more efficient and make it faster for our technicians to actually build the spacecraft or build the components. So if you think about the old technologies where you'd have to have a drawing and you'd have to go look at that drawing and measure out where like click bonds need to go on the spacecraft, they'd have to go look at the drawing, they'd have to go to the spacecraft, they'd measure it out. Now that you can use augmented reality goggles, or they can hold up an iPad, and it aligns it right up with the model and the software, and they can click bond away. So when you're doing training, we've seen reductions as much as 85% in training, and when you're talking some of our actual production activities, we're seeing efficiencies up to 90%. So there's some operations that used to take, like click bonding, that took 8 hours, that's reduced down to 45 minutes. So you can see as we're starting to produce these vehicles, why these technologies are key for us to be able to provide that sustainable, efficient transportation for crew into space and humans into space. Now, I have to admit, transportation is just one of the elements there, but that's the one I'm most fond of course, and I'm closest to. But there's also power. We talked a lot about that earlier today. Nothing can be done without energy, and a lot of it. So at Lockheed Martin, we're starting to look, a new landscape requires new power sources, and so we're really investing in nuclear energy, fission-based surface power, and solar power. Those are just a few of the things that Lockheed's investing in. Habitation. Humanity needs a home on the moon. We've talked about that a little today. At Lockheed Martin, we're really investing in that inflatable habitat and also that mobile habitation capabilities at Lockheed Martin. Surface mobility, there's getting to the moon like you will in Orion, but what do you do once you're there? We're starting to look at different ways that we can have lunar mobility on the surface of the moon, transporting not just humans, but all of our equipment and all the resources that were needed. And last but not least, this has come up a couple times today, we need position, navigation, and timing, and communications. That fast communication as we travel to the moon, those data comms when we're on the moon. I think it was Alan that mentioned earlier about GPS being a benefit that we got from space. Well, part of my bio that he didn't tell you about, my previous position, I led all of our position, navigation, and timing portfolio for Lockheed Martin in the navigation systems area. So think of all the GPS-3 satellites and the GPS-3F satellites and that satellite production line. So we can take the capabilities from that PNT system and put that on the lunar surface. Just like we're taking some of the the production processes and the production mentality that my team used on GPS 3F production, where we produced 10 vehicles in the span of just 5 years. And we're taking that to human spaceflight for Orion, too, as we move into our production phase of the program. And lastly, ISRU, water and propellant. We're looking at ways to make sure that we can get there and have the tooling on the surface to make it happen. A quick nod to Walt. I was going to be able to give Amit, who is my customer's leader, a nod. But one of the things that's really helped enable this for Lockheed Martin, they talked a little bit about NASA's Moon to Mars architecture. And that's been a really great guide for companies like Lockheed Martin looking to make a cislunar economy a reality. Another element that I want to touch on before I get off this slide that we haven't talked or I haven't heard that much about today is commonality and really having a common framework for what it's going to take to develop a long-term lunar ecosystem. And then start talking about those open standards and that open architecture. That'll be really key, especially as we start to see international partners want to explore with us. I'm going to talk about our workforce. So a common framework for the future lunar economy must be a cross-sector workforce because it's going to be complex. And we need a wide breadth of skills from science, engineering, technology, and more. With that in mind, critical talent is something we should all be thinking about. Since September of 2022, Lockheed Martin has worked with the National Space Council and NASA on a space-skilled technical workforce initiative. And it's really for that non-traditional workforce and looking for pathways for careers for folks to get into the space industry, focused on those that don't have 4-year degrees. A couple ways we've done that. We've actually served as an anchor company for the regional pilot on Florida's Space Coast. We've been working closely with Space Florida to better align education and industry training opportunities for the needs to better meet the needs of industry. At the state level, Lockheed Martin has also informed Florida's master credential list. Think of that as a menu of training opportunities and a space academy of sorts to be marketed to educational partners, students, parents, even adult educators. On Orion, on my program, we've actually leveraged some of these relationships in really cool ways. We actually had an instructor. The instructor was from that district's aerospace and aviation assembly program. His name was Bill McKinnish, and he came out and we taught him all about wire harness assembly and how to do forklift and aerial lifts that we do in our high bay. And he, by the way, was the Space and Air Force National Teacher of the Year this past year. But he took that back and he's expanding his curriculum to take those skills that we need in our workforce that are in high demand, and he's putting that into the curriculum so that benefits the students for their future work, but also benefits our industry. So it's a really cool way to partner to make sure we're getting that between the educational system and actually bringing it into the workforce. We also hired this past year 3 new Brevard High School graduates. Young people that came in right out of high school. One of them I'll tell you about, her name is Lauren, and she is a bright spot on our team. Her supervisor talks about her all the time. She's got such great energy and dedication. All the other technicians can't wait to work with her because she's so willing to learn. It's been a really great example for our workforce who might have had misconceptions about people coming straight from high school, but really leveraging that apprenticeship, and it's been a great tool to bring non-traditional folks onto our team and have a really strong workforce. And Lauren's paving the way for that because now everybody wants to find those new high school grads that we bring on our team as apprentices. But it doesn't have to be government-driven like the coalition. One of the things we started at Lockheed Martin 7 years ago is our AMTAP program. It's our Advanced Manufacturing Technician Apprentice Program, AMTAP. We've had it for 7 years, and it's basically a 6 to 9 week boot camp. We bring in some of these non-traditional workforce folks. They come in, they get trained, and then they're out working on the floor, whether they're working in my high bay at Kennedy Space Center or working in some of our production centers. To date, we've had 428 folks come through that program, and over 7 years, we've retained 310 of them, which is actually pretty high for that technician workforce. We've seen a lot less transition there. And to date, those employees are really enjoying being part of the team. They like being able to be hands-on and be part of this historical time, right, as we're taking humans back to deep space. So as I wrap up here, I see I've got 30 seconds left. I'll close up. The future lunar economy is something that will require a diverse skill set to build that complex infrastructure. And we really need that common framework that brings a cross-sector, cross-industry group forward to develop that. And if humanity really wants to go to the moon and stay there, we'll have to work that together. Space is definitely a team sport. We've seen that. Lockheed Martin wants to continue to work with other partners in the industry to make sure that we have that sustainable human presence on the moon and make that a reality. Thank you again for your time today. Thanks for listening to me, and I look forward to working together as we move beyond Earth.